Okay, now the fourth questions in kinematics of simple harmonic motion. Okay, let us read the question together. The equation of a simple harmonic motion of a 600-gram object is given by 0.45 cos 6.4 t, where the displacement is in meters and time in seconds. Okay, I want you to pay special attention to the time. Okay, he said the displacement is in meters, time in second. Okay, what is the total energy of the system? Okay, what's the total energy? Question asks for the total energy. Okay, so you have a equation here. So pay attention. It is a cos equation, right? All right. So he asked for the total energy. Okay, so this equation is very important. Okay, this is about the displacement equation. Okay, mass is given 600 gram, which is also 0.6 kilogram. Okay, the equation, this is a displacement equation. Okay, so I compare it with the general formula for displacement using cos. So I also using cos. Okay, a cos omega t. I compare with the displacement equation. So I got the value for amplitude. Here I got amplitude is 0.45. Omega is 6.4. Omega is 6.4. Okay, unit is x is meter, t in second. Okay, so why I say the unit is very important because he say the displacement is in meter. That means the amplitude also meter. Amplitude also meter, and the time is second. So the omega is per second. You must get the unit correct. If the displacement is in cm, the amplitude also cm. If the time is in millisecond, then the omega is per millisecond. So be careful. Okay, so I want to find the total energy. So the formula for total energy is half m omega square a square. So total energy depend on amplitude. The bigger the amplitude, the higher the total energy. So do we have all the information? Yes, we have the mass, we have the omega, we have the amplitude. Is everything in SI unit? Yeah, mass I convert from gram to kilogram already. Omega is in second, per second, and the amplitude is in meter. Okay, no worries about the unit, all in SI unit. So I just substitute everything. So mass is 0.6 kilogram. Omega is 6.4 per second, where it amplitude is in meter. So all in SI unit. Just substitute with peace of mind. Okay, this one is in meter. Okay, unit is in SI unit already. Okay, so what's the answer? What's the total energy? Yes, it is 2.49 joule. Is that the answer? 2.49 joule? Yes, 2.488 joule. So which is also 2.49 joule. That's correct. Okay. Now B. One end of a tuning fork vibrates in a simple harmonic motion of frequency 1000 Hz and amplitude 0.4 millimeter. So this is the frequency and this is the amplitude. Be careful, the unit is in millimeter. You need to change to meter. Find the speed at equilibrium position. Okay, so the question asks for speed. Sorry, the question asks for speed at equilibrium position. Okay, so the information we have is the frequency, 1000 Hz. Amplitude, okay, is in millimeter. So make sure you change to SI unit meter. So exponent -3. Okay? Now, what is the speed at equilibrium position? Okay, speed at equilibrium is the maximum speed. Do you remember? Speed at equilibrium position Maybe we can refer back to the notes about the here. This one. Still remember this one? Equilibrium position. You see the equilibrium position. The speed is maximum. At equilibrium position, speed is maximum a omega. If at the amplitude, the speed is 0. So the block moves the fastest at equilibrium. Maximum speed at equilibrium, a omega. Okay? So the question, speed at equilibrium means what? Speed at equilibrium means maximum speed. Maximum speed, the formula is a omega. Okay, a omega. Maximum value. So a omega, do you have the a? Yes, we have the amplitude already. Amplitude omega, don't have, but we have the frequency. So frequency, we can find omega. Omega is 2 pi f. So let's find the omega first. 2 pi f, f is 1000 hertz. 1000 hertz. So omega is 2000 pi. Omega is 2000 pi radian per second. So let's substitute. We have all the information already. Omega A is 0.40 exponent -3. And then omega is 2000 pi. Okay, 2000 pi. So what's the answer? What's the answer? Is 4/5 pi the answer? Or it is also equal to 2.51 meter per second. That's the answer for maximum speed. Or speed at equilibrium. Yeah, 2.51. Yes, it's correct. Now, next one. What's the acceleration at amplitude position? Oh, this question asks for acceleration, but at amplitude position. So at amplitude, okay, let's look at the amplitude. Let's look at the amplitude again. Yeah. So at the amplitude, what's the acceleration? The acceleration at the amplitude is maximum, which is a omega square. So the negative sign just ignore, because we just want the size of the acceleration, the maximum acceleration, which is a omega square. So at amplitude, the acceleration is maximum, but at equilibrium, acceleration is 0. Because acceleration depends on displacement. Acceleration is proportional to displacement. At equilibrium, displacement is 0. Displacement is 0, so acceleration also 0. Acceleration is proportional to displacement. So when displacement is 0, acceleration is 0. When displacement is maximum, acceleration also maximum. Okay? Which is acceleration is maximum is a omega square. Yeah? Because depend on this formula, a equal to negative omega square x. Acceleration is proportional to x. So when x is maximum at amplitude, so acceleration also maximum. You just imagine the spring is being extend, extend at maximum. Maximum displacement means full expansion. The string is being expand at full. So the spring force, of course, very high. The string would want to pull back with very high force. The higher the restoring force, the higher the acceleration. Okay? Because F equal to ma. The higher the restoring force, the higher the acceleration. So, anyways, maximum displacement, maximum acceleration. Acceleration is proportional to displacement. Okay. Now, let's look back to our questions. All right? Let's look back to our questions. So, acceleration at amplitude. Okay, acceleration at amplitude is maximum acceleration, which is also a omega squared. Just ignore the sign, because we just want the size of acceleration, maximum acceleration. Okay. Now, so the amplitude is 0.4. Just substitute. We have the amplitude and omega already. Yeah, just substitute. Okay. Now omega is 2000 pi. Omega is 2000 pi square. Okay, so what's the answer? What's the answer? It is 1.58 exponent 4 meter per second square. That's the acceleration, maximum acceleration. Maximum acceleration. Maximum acceleration. When asked to find maximum acceleration, that means you just want the magnitude of acceleration. No sign at all. Yeah, we don't want the direction. We just want the magnitude of the maximum acceleration, which is 8 omega squared. So no positive negative sign. Okay, so it's 1.58 exponent 4. Okay. Now let's look at the question 3. What is the speed and acceleration when the displacement is 0.2 millimeter? Okay, so I want the displacement and acceleration at given displacement. Okay, so this one given displacement, us to find that speed and acceleration. That means I need to use the formula v versus x and also a versus x formula. A versus x formula. So this is the formula v versus x, a versus x. Okay. So I have the information. Do I have the information? It said displacement is 0.2 millimeter. So this is a displacement. So this is a positive displacement. This is a positive displacement. Okay. Okay. Now, so the displacement is positive 0.2 millimeter. Okay, so change to SI unit. This is not in SI unit, milli. So you must change 0.2 exponent negative 3. Okay, millimeter. All right. So what's the omega? So omega is 2000 pi. Amplitude is this one. Okay, so just substitute inside. Okay, so 2000 pi and amplitude is this one. Okay, we already got the information, just substitute. So 0.40, make sure everything in SI unit. Yeah, millimeter need to change to meter. Square, and then minus this one, 0.20 exponent negative 3 square. Okay, sorry. So yeah, so just get answer. So the answer is positive negative. Yeah, so the answer is positive negative 2.18. Okay, this one, it doesn't ask about maximum speed. This one just asks for the velocity at this position. So this one you must give the sign. Okay, what it means? It means that at this position, at this displacement 0.2 millimeter, the object can have two possibilities. It can, maybe it's moving up, maybe it's moving down. So there's positive negative sign just to show the direction. Maybe it's going up or going down at that position. Okay, it can have two possibilities. Two possibility of direction. Maybe it's going up or going down. Okay, because it doesn't give the actual time. If you have the actual time, we can know definite. For definite, only one direction. But he give the displacement. He give the displacement. It can have two possibility of direction. Maybe it's going up or going down. So we just put positive, negative sign, right? Now, for acceleration with displacement, so we use the AX formula, which A equal to negative omega square x. So the displacement just now is this one, yeah, positive 0.2 millimeter, change to meter. So omega is just now 2000 pi. So substitute. Okay, negative 2000 pi square. So the x is 0.2. Okay, so what's the answer? The answer is negative 7.90 exponent 3 meter per second square. So this one is yeah, so negative. This direction, you can see acceleration is negative. It means that it is maybe to the left or downwards. Okay, the direction. So of course, because we say when displacement is positive, acceleration must be negative. When displacement to the right, acceleration to the left. When acceleration is upwards, acceleration downward. Because why you say? Because acceleration always opposite x. Acceleration always opposite x based on the a equal to negative omega square x because of d sine. Okay, acceleration is always opposite the x. Right? Good. Now let's look at the last question. Deduce an expression for the displacement in terms of time t. Assume that when time equal to 0, the n is at equilibrium. Okay, you see the last sentence here, assume at 0 time, the n is at equilibrium. N is at equilibrium. This means that the phase constant, yeah, the phase constant, or we can say the initial phase angle. Initial phase angle is 0. Okay, so the equation is simply, all right, let me, okay, so initial phase angle is 0, so A is equal to A sine theta, no phi, no phase angle. Yeah. So the graph also start from equilibrium. So that means it's a sine graph. The sine graph. Yeah. It is a sine graph like this. It start from, at 0 second. At 0 second, the graph start from 0. Okay. So it is a sine graph. So this one. So the general formula is x equal to a sine omega t. So what is our A? What is our amplitude? Amplitude is this one. And the omega is 2000 pi. So just right inside. Yeah. So x is equal to, because we know that this is in millimeter, so we can change to 0.40 sine omega is 2000 pi t. Now you must write x in millimeter. Why? Because our amplitude is millimeter. Our amplitude is millimeter, so our displacement also millimeter. You must write the unit. This part very important. The unit. Okay. So and then t in second. This one you must write. Yeah, the unit. The unit very important. Okay. So that's our equation, right? So maybe we can write where x in millimeter, t in second. Okay, that's all for question 4. So I hope you enjoy, you understand. If you don't understand anything, please leave a comment below. Yeah. So see you in the next question. Bye.